Okay, I think we're going to get started. Thank you everyone for coming. And hello, my name is Sandro Peruzza. I'm the CEO of the Ontario Society of Professional Engineers. Today, as everyone knows, or hopefully everyone knows, March 1st is Professional Engineering Day here in Ontario. And I'm delighted that you're able to join us and celebrate that with us tonight. Knowing tonight's panelists as well as I do, it'll be treated to a spirited discussion around the future of engineering education. Hear that, panelists? A spirited conversation. And it will be, because I think the future is bright and there's a lot of opportunities. For those, again, that don't know what P.Eng Day, it is actually formally recognized by the provincial legislation, and it's something that OSPE lobbied for years ago, actually 6 years ago to be exact, to elevate the profile of the profession within our community. I hope that throughout this evening you'll have enjoyed the programming on our social media channels, including the many comments acknowledging the importance of professional engineers to improving both our quality of life and society as a whole. Speaking of that programming, this year we spoke to some young people and asked them to engage professional engineers on a number of different topics. We have a number of videos and we're going to show you a sample of one of those right now.
So kids, what do you think an engineer does each day?
Build vehicles and fix electronics.
I think an engineer fixes cars and other stuff.
So I think an engineer, well, there's many different types of engineers. There's computer engineers, car engineers, regular engineers, but they most likely work on stuff and fix stuff to make them better.
What skills do you think an engineer needs?
I think an engineer needs to be able to prepare a lot beforehand. I think they need to be able to apply their skills usefully, and I think they need to be able to change their plans if something doesn't go according to plan.
I think the skills that an engineer needs is what objects do they need, what kind of material does it have to be made out of, and how will it move, does it even move, and how it is going to be built.
Thank you, engineers, for everything you've done. Bye.
We have the full suite of videos on our YouTube channel, so please check them out at your convenience. So every year, when we celebrate P.Eng Day on March 1st, we want everyone throughout the entire province to celebrate along with us. This year, we have arranged the CN Tower to be lit purple this evening as part of the festivities. So please check it out on your way home if you happen to drive by that way, or even if you don't have to drive by that way, maybe do a little detour and check it out. But you can also live stream it on their website. Today is also the first day of National Engineering Month. Throughout March, all around the country, on campuses, in communities, there will be a series of events for and by the engineering community. In addition to tonight, OSPE will be hosting fireside chats with our Advocacy Task Force chairs to explore the issues they are working on today and throughout the year of 2023. So there are the dates that we're hosting these, so please log on, register, and listen and participate. Because part of this is we also want our members to provide input on the work that they're doing. So let's get on to tonight. I'm very excited about this evening's programs, but before we get to that, I want to thank our partners. Without their support, we cannot be able to serve our members and host events like this. OSPE's partners for 2023 include The Personal, National Bank Financial, BMS, Notarius, Epic, and Manulife, Corestone Law, Member Perks, the Association of Consulting Engineering Companies of Ontario, the Ontario Association of Certified Engineering Technicians and Technologists, Commonwealth, and Mercer, as well as our many supporting organizations. I also want to thank all these other gracious organizations as well. So now it's my great opportunity and pleasure to invite Jennifer Qualietta, P.Eng, the new CEO and Registrar of Professional Engineers of Ontario, our provincial engineering regulator, to say a few words. Jennifer, I can still call you new, right?
Thank you, Sandra, for that warm introduction. I thank you and your marvelous OSPE team for inviting me to the beautiful Ontario Science Centre to help kick off National Engineering Month. Good evening, everyone. As Sandra mentioned, my name is Jennifer Qualietta, and I am the CEO and Registrar for the Professional Engineers of Ontario. For many of you today, this may be your first time meeting me. I was welcomed into the role just 2 months ago after the retirement of Johnny Zucon. Johnny had a 27-year career at PEO, and it's thanks to him and his leadership that PEO in recent years has become more focused on its regulatory mandate while leaving the engineering advocacy activities to OSPE. And I look forward to continuing to build on PEO's positive working relationship within our two organizations. In Ontario, PEO, professional engineers, and engineering students and educators all have a role to play in engineering education. This evening, you will hear from the Deans of Engineering and Applied Science faculties from Lakehead, McMaster, and Humber College. If you are a student, whether here today or listening online, the talk today will be very important for you. And while I am here today in my role as CEO and Registrar at PEO, I am also a chemical engineering graduate from the University of Toronto, a lifelong learner, and an investor in our future leaders. As that person, I'd like to share with you what I've learned along the way as a professional engineer. First, your engineering education is the stepping stone to roles that will help shape society and its future. Engineers are involved in every aspect of everyday life. We build cities, we design software, we create food, we keep critical infrastructure running, and much more. The engineer of tomorrow needs to be multifaceted and global. Increasingly, engineers must embrace teamwork and strong communication skills, along with their technical and problem-solving skills. As you heard, as many of those children said, we love to fix problems. Just as the world changes, so too must engineering programs evolve and adapt, and they are. Whether it's multidisciplinary design at the University of Ottawa, or engineering and nuclear engineering at Ontario Tech, engineering programs are no longer just about the traditional disciplines. Ontario's engineering faculties are also increasingly interdisciplinary. For example, McMaster offers a unique 5-year program in engineering and society and engineering and management. And Lakehead engineering students concurrently earn both an undergraduate degree in engineering and an engineering technology diploma. Ontario has 15 engineering faculties, and many Ontario colleges are offering engineering education. It's no surprise that Canada is home to some of the world's best engineering programs. Having a solid educational foundation that reflects the engineer of tomorrow is an important step towards preparing you for your future roles, but it's just the beginning. Which brings me to my second insight, that the journey of an engineer is one of lifelong learning. Professional engineers have a commitment to protect public safety and the environment, but they also work to protect our economies and their employers. It is crucial that engineers maintain their technical knowledge and stay informed of the latest regulations impacting the profession. As a well-known engineer from Ontario, astronaut Chris Hadfield once said, "I never stopped getting ready, just in case." This past January, PEO made its continuing professional development program, called PEAK, a mandatory part of its annual licensing process for all professional engineers and limited license holders in Ontario. PEAK supports license holders to maintain their skills, their competency, and their professionalism through continuing professional development. Participation in 2023 has been remarkable. Just over 72% of our members have completed the program, which I believe speaks to the commitment that professional engineers have to continuous learning and expanding their skills. Finally, my third insight for you is that great things happen when we are generous with our knowledge and we stay connected. Think about all of the teachers, the mentors, classmates, and colleagues who you are encountering on your path to becoming an engineer. They're investing in you because the work you will eventually do, or maybe doing already, is extremely important. As engineers, we have a broad range of responsibilities, but at the core of what we do is solving problems. Remember that behavioral skills such as teamwork are of equal importance to the technical engineering knowledge that you're gaining. Team problem solving generates more solutions and greater and more productive outputs than any one person can generate alone. So, for the students here, share your knowledge by networking with your fellow engineering classmates, your colleagues, and your professors. Become an OSPE member and stay connected with your university and college after you graduate. And if you're ever in PEO's neighborhood, please feel free to drop by and learn about what we do as a provincial regulator. With that, I wish you all the very best in your path to finding meaningful and fulfilling opportunities as future engineers. Thank you again for having me here tonight. And I would now like to invite Dr. Farzad Rayegani, Senior Dean of the Faculty of Applied Sciences and Technology at Humber College, to come up.
Thank you, Jennifer, and thank you, everyone. So nice to meet all of you, and I don't know that if I need an introduction or introduce myself, because talking to some of you, we were talking about the project that we did 20 years ago and 25 years ago, and still we are here and asking that still you are here, still you are in a part of the community. This is the engineering community that we are. We never leave. So, good evening, and thank you, Jennifer, for your warm welcome. I'm Farzad Rayegani, Senior Dean of the Faculty of Applied Sciences and Technology at Humber College. And as professional engineer and fellow engineer of Canada, I wish you a happy P.Eng Day, and we kick off the National Engineering Month at this in-person and online event. It is so wonderful that the engineering community can come together for both online and in-person event to host bold and insightful conversation during this annual month of long tribute to engineering. Humber College and the Faculty of Applied Sciences and Technology is proud to be a champion partner of National Engineering Month, and I am so honored to participate in the year's kick-off the event and explore the future of engineering degree and education with my colleagues. We as a society, and especially our educational system, play such an important role to inspire and empower the next generation of the leaders and encourage students to consider career in STEM and more specifically engineering. Industry report shows significant and growing need to replace retiring engineers. In the traditional area of the civil, mechanical, electrical, computer engineering, while we need more engineers in emerging technology, as Jennifer mentioned. Disciplines like mechatronics, system engineering, information system engineering, and so on and so on. Also, depending on where you are in Ontario, North Ontario or in the GTA, you face unique challenges. Distance may be a challenge, a community and the demand can be a challenge, and labor market can be a challenge. So during our panel discussion, my esteemed colleagues and I will discuss how engineering programs are changing to meet the demands of tomorrow's workplace and ensure that engineering education remain relevant, respected, and valued. I hope that I have a chance to highlight Humber new Bachelor of Engineering program in Mechatronic Information System, built environment, and how they are meet industry demand for graduate from emerging technology field, and a strengthening opportunity for learner to prepare for career in high skilled. But as these little kids are mentioning, at the heart of the engineer is a caring professional who is driven and committed to the advancement of civilization and help increase the quality of the life for healthcare, transportation, workplace, manufacturing, and so on, and in your home. We bring a caring sense of humanity by defining problem and finding solutions to improve the quality of our everyday lives. The challenges facing engineering today are not those of isolated locals, but of the planet as a whole and as one community. We must work together to meet these challenges, and as an educator, we take our role very seriously. We are accountable for providing engineering graduates with a set of skills and competency to prepare them for their engineering profession so that they can positively contribute to our society and help make the world not only a more technologically advanced and connected place, but also a more sustainable, safe, healthy, and joyful world. Enhancing the joy of living remains a top priority of engineering innovation, and today's panel includes representatives of the educators that are committed to developing the next generation of engineers. I am looking forward to the high-impact discussion with my colleague and engaging with all of you. Thank you for Ontario Society of Professional Engineers and Engineer Canada for hosting Canada's largest celebration of engineering excellence. I also want to extend a heartfelt thank you to all the volunteers who are coordinating event all months long. We truly appreciate your dedication. Thank you for attending tonight's kickoff, and I look forward for our next hour of the transparent, insightful discussion with our panelists. Thank you.
Thank you, Farzad. And OSPE is very grateful that Humber College is the leader partner for National Engineering Month this year. Now let's get on to the content for this evening. For close to a year now, it's been my great pleasure to work closely with Dr. Marilyn Powers, professional engineer, as OSPE's president and chairperson. Marilyn is passionate about many things, but amongst them, primarily the top one is education. So she was a natural choice to be the moderator of tonight's discussion on the future of the engineering education. So Marilyn, please join me on stage to introduce our esteemed guests.
Good evening, everyone. As Sandro said, I am very passionate about education in general, and that's because I spent my entire engineering career building technology to help people learn. So I started back a couple of decades ago doing virtual reality and surgical simulation, trying to make sure that the surgeons had a safe place to train. I have done hardware, I have done software, everything in between, and now I'm the director of academic technology at Mohawk College, where I am taking Mohawk through a digital transformation in teaching and learning, making sure that not only the faculty can teach the skills, but the students have all those digital skills that we know they're going to need throughout their careers. So I am thrilled to be here tonight, to be working with this esteemed panel and finding out their views on where the engineering degree will go. And so without any further ado, you've already been introduced to Dr. Farzad Rayegani, and I'd like to call up Dr. Heather Sheardown from McMaster University, Dean of the Faculty of Engineering there, and Dr. Janusz Kozinski from Lakehead University, Dean of the Faculty of Engineering. So, everybody take a seat, and what I'll do is I will have Dr. Sheardown. You can introduce yourself, and then we'll go to Dr. Kozinski.
Absolutely. All right, I'm Heather Sheardown, and I say always, I have the distinct pleasure of being the Dean of the Faculty of Engineering at McMaster. It's funny, I had a colleague when I started as a faculty member say, I want to be Dean, I want to be Dean. And I said, oh my gosh, I don't want to be Dean. Why would you want that job? But it's actually the best job in the world. I get to deal with students, grad students, amazing faculty all the time. My research is medical. That hasn't come up yet. So engineers also make a huge difference in medicine and growing as the pandemic has shown us. I think a lot of the innovations that came out of the pandemic were really driven by engineers. There's no way we could have made the vaccines that we made as quickly as we did without engineers. So I'm very proud to be part of that training.
Dr. Kozinski?
Thank you very much. Welcome, everyone. Thank you so much for inviting me to speak about something that I'm very, very passionate about, as my colleagues are no doubt as well. I was born and raised in Poland, so I'm a proud Polish Canadian. And I'm also, yes, we have some colleagues. And I think I may look at myself as an academic globetrotter. I worked in the United States and in the UK and in France and in Canada. All of those places, my wife and I, and she's right here as well, we found Canada as the very best place. And the other thing that perhaps I may comment about is that together with my team, and some members of my team are here as well, we created a completely new engineering school at York University, Lason School of Engineering, not long ago. Then we created a new technical university in the UK that is doing very well. And now we are creating something that we believe will be an extraordinary engineering project, somewhat controversial, and I will be sharing with you those comments later on. Thank you.
Thank you so much. So I always introduce, at least in my faculty and in my college, myself as a professional engineer first, and after that the Dean of the Faculty of Applied Science and Technology. And there is a reason for that, because I look at the engineering education as a system, because we call it engineering education system. And always I wanted to apply the system theory into the system. So my background is in 80s, 90s when I graduated, there was a computer integrated manufacturing and it was the informatic. I couldn't choose between these two and I got both at the same time. I worked in four continents before coming to in Canada. Most of, that is I can say, most of 15 years in Europe. After that I was in Asia before, and I was in Africa. And I came to Canada and bringing experience of educational system, 4 different educational systems that I lived with and suffered to come to develop an engineering degree that I think that it makes sense. Talking to some of our colleagues and having some discussion here. But the whole idea is that engineering is changing. Engineering education should be changing, and we will have a discussion for here. I am so happy to see. Thank you.
Excellent. Thanks, everyone. So we'll get right to questions here. And what I'll do is I'll ask questions, and then we'll rotate through the 3 of you. Once we're through a few of them, we're going to turn to the audience. So the audience has a chance to ask questions, and those who are joining us online, we will take your questions online as well. So let's get started. Many of you may know, and if you don't, the Canadian Engineering Accreditation Board actually sets out all the standards for engineering programs right across the country. And there's a lot. There's a lot to those requirements. And what that does is it makes it hard for universities to start differentiating themselves. And we all know, as that smart young man said on the video, engineers do a lot of different things. So could you tell us, in your engineering programs, what sets your programs out differently for the students who are choosing them? And we'll start with Heather.
Yeah, I mean, one of the things that we've recently done with our engineering programs, and it crosses all of the disciplines, is that we've really embedded experiential learning into the program. So our first year now has a very large course. So when I first heard about this 13-unit course, and for those of you who are familiar, that's equivalent to about 4 courses. We put all of these 4 courses in, but as a project, and all of the first-year students do it. And The projects are typically from the community. So last year it was a gentleman who had mobility issues because of a health problem that he was having. And they were asked to design widgets that would help him in his daily life. So silly things like he couldn't pour tea. He couldn't deal cards, and he loved to play cards. To more difficult things like, washing dishes and carrying groceries into the house and that kind of thing. I thought, there's no way. So they do some programming. They do a little bit of, they do some stuff with robots. So we've got some robotics and programming in that. I went into what we call the design studio in February of last year. So it was our one course that was in person all year. The students were in person the whole time. And I've never seen more Amazon boxes in my entire life, because everything that they made was out of cardboard initially, cardboard and duct tape, and then they would 3D print it, and they'd go through the iterations, all of those things. And I thought, wow, these guys really understand engineering. They're engineering in their first year, and I don't think any of us that went through school in the 80s can say that we actually did any real engineering in our first year. And then it cross-cuts into second year and third year. And they're, again, across the department. So the students are working with electrical and chemical and mechanical engineers on a problem. Last year, the problem had to do with waste. So the design projects had to do with, how did we deal with the waste problem? How did we recycle things better? How did we sort things? And they all had a slightly different problem. But again, it was all about engineering. It was about transportation. It was about the recycling plant. It was about the materials. It was about all of that stuff. And they had to work within their teams and bring out the best in them. So I think that the experiential learning piece at McMaster is really what's different. I think the other thing that we've added to that is experiential learning goes beyond the classroom. So we've got a number of different programs that allow the students to get experience beyond the classroom. So our clubs and teams, for example, I was in the bays today with the students, and it's amazing. They're building buildings, scales of buildings. They've got a Baja car that they want me to drive. I'm a little frightened by that. They're building rockets that go up into the sky 3 kilometers, and they have to hit certain milestones and that kind of thing. And they get credit for this. So they're doing engineering, and they don't realize it. But it's all experiential. They have the opportunity to really learn, but while they're just loving it. I mean, they're learning to weld, and they're learning to, things like, I remember learning in my second year what a Phillips screwdriver was, because nobody knew. Well, these guys have no problem with that. They're welding, they're machining, they came to me in the fall and asked if I could arrange for them to have access to a CNC machine. And I was thinking, boy, that wasn't the case. So they're really experiencing what it's like to work as an engineer, how to solve a problem, how to work in a team, and we give them credit for that. And then there's some outside activities as well. So it's all about experience, and I think that will build us some lifelong learners who will go out and continue to build on what they've learned.
That sounds really exciting. So, Janusz.
Yes, and thank you, Marilyn. Look, so I strongly believe that the future is less about answering questions and more about questioning answers. And if so be it, then we have to change our education so we are not just focusing on developing certain set of skills for our students. It's all about mindset. Now, and it's even further than that. I don't think that we should have the way that we are educating students that they can get a job after graduation. It's all about getting a variety of jobs during one's career. So that is what I love about Lakehead. And Jennifer already mentioned it, which is this focus on employability, the opportunity for young people to come to the university and get an opportunity to get a diploma if they wish so, and then continue and get a university degree as well. And in addition to it, the only engineering program in the entire country that allows engineering students in the final year to concurrently study for MBA. I mean, that having a diploma and a degree and an MBA, it's a terrific combination. It is all done concurrently. So we are proud to say, we call it an open engineering model. We developed a model that actually serves everyone, including those without the prerequisites. I'm sure we're going to talk about prerequisites later on as well. But I wanted to comment about two programs that we are now developing that are very, very different. So one, we call it Invictus Engineering. It is the engineering program that is developed especially for wounded servicemen, servicewomen, veterans transitioning from military to civilian life. And these are the people that protect us every day, that contributed so much to the community. And because of their abilities or disabilities, they would not be able to participate in a traditional engineering programs. On the other hand, they have absolutely terrific foundation, technical foundation, and management and leadership. So we've developed that program, and we hope to start delivering it very soon. And the other program that I wanted to comment is a sort of engineering equivalent of MBA. You see, so we call it a Master in Integrated Engineering. Typically, in our field, if you want to do masters in, say, mechanical engineering or electrical and so on, you're going to study a little bit more and a little bit narrower field. We don't believe that that's the future, so we developed a Master of Integrated Engineering. That's the program that integrates all of the aspects, if you wish to call it disciplines, so be it, disciplines in engineering, and it's exclusively based on projects that are developed, that are delivered by our industrial partners. So, you know, you always want to be different. You don't want to be odd, and that's how we are focusing our future at Lakehead. Thank you so much.
Thank you so much. Yes, I think that we heard about the evaluation of the engineering education. I go back to the system, and when we have education system or here engineering system theory applied. So when I look at the industry behavior, it's changed during the last 20, 30 years. So when I come from the graduate from the engineering program, I was hired by an industry. They told me that I will train you for 2 years. I have already the problem. I hire you to solve the problem. But today's graduate will face that interview a little bit differently. They will hire and say, I don't know what is my problem is. I hire you to first find the problem, and after that solve it for me. So that is a huge difference. By the way, I don't train you. I need you to be ready first day to contribute to my company. That is a huge difference. I see it from my son who is graduated and hiring. So what should we change in our program? So every day as an engineer, when we face such a situation and we go through the problem solving, we have that cycle with the 4 things. Conceive, it means that I work with the client to understand what they are thinking, and eventually come to the conclusion that this is your problem. After that, I design the system, but it's not a stop. Engineering work doesn't stop here, so I have also to implement. It means that I have to build this system, and after that to operate that system. And operation means that I have to think about the sustainability of what I build. It's not that I build and after that I throw it. I cannot take consideration sustainability and reusable and recyclability and so on. So it means that in our program, we go from the first year, conceive, design, implement, operate. Of course, with the less complexity that the students of first year can handle it individually or as a small group. After that, in the second year, we increase the complexity, increase the discipline, different discipline, and in the third, again, the complex, and in the fourth year, now they have with the industry partner come really go through the whole cycle of the conceive, design, implement, operate to solve the problem of the industry. So I can give it you in this example. Imagine that your kids are playing soccer and you don't allow them to touch the ball the first week or first semester and say that, no. You first must learn about the history of the FIFA, the second, the rule of the FIFA, or also learn about the tactic, but don't touch the ball. Don't touch the ball. So, doesn't make sense. Yes, it's laughable. Why we should do it in engineering education that don't touch, let's learn about the math and integral, but separate in a silo from 8 to 10 a.m., let's learn calculus, 10 to 12, learn fundamental of physics. Next day you come and you have to understand that how you integrate these things. Doesn't make sense. So please, let's rethink about the engineering education again and again. Thank you.
Wow, so some very good differentiators, and I'm a little bit jealous. Engineering's already changed quite a bit since I went through, apparently. Another thing that I've been able to go out and talk to lots of engineering students in this past year, and I have been amazed at how engineering still has a reputation, but even a bigger reputation about how much content these students have to get through. And they're working really, really long hours to do that. So we're going to spend the next few questions talking about what needs to change. But let's start with what needs to stay. And I'm going to start with Janusz, and then we'll go around that way.
Yeah, so you see, engineers create everything that isn't naturally created. It's a huge responsibility. By the way, if you look around this room, I think perhaps everything what is there we created, with the exception of you human beings, although we likely participated in it. But that is a huge responsibility that we really have to undertake. When we look at the engineering education currently, I think there are two elements that we have to preserve. So it's an academic rigor and entrepreneurial spirit. I mean, young people, they have that spirit that show us every day. I liked very much those future engineers that commented about their own meaning of engineering when you show the video. Now, if you look at this, currently what's happening is that we are changing the way, or engineering technology is changing the way how we do things, what we do, and importantly, who we are as human beings, and particularly how we're going to interact with robotic process automation and with artificial intelligence as well. I think, and I'm sure we're going to talk about what we need to change, and we have to find a way of being tradition innovators. That means respecting traditions, but innovating around it. So the change is inevitable. And I remember some time ago when I participated in some professional development programs, I was told that the only person that really likes change is the baby with a wet diaper. And it is true, I spoke with a colleague of mine from another university here in GTA not long ago, and we were talking about those changes, and he said, well, when he talks to some of his colleagues, says that little change is good, no change is better. And that's not the mindset that we would like to have. Well, so there are some elements, important elements that we have to maintain, but in my opinion, there is significantly more that we have to, that has to evolve and likely change as well.
Yep. Yes. Thank you so much. So I work with the global engineering educator globally, and one of the concerns they had always was that, as engineering students, they have to know the fundamental and principle and engineering law and the science and all. And if I teach all these, there is no place for the communication, teamwork, and the entrepreneurship. I don't have a space. The trick is here. Let's go back to our soccer example. The fundamental of the soccer, if you wanted to play soccer, you have to have a physical ability. Now imagine that if I have 100 hours and 80 hours I spend in a gym to get stronger, so I don't have enough time, only 20 hours to have 10 hours technical and 10 hours tactical practice. But if I integrate everything together as a scrimmage, while we are playing, I am running, so my stamina is getting stronger and stronger, I am getting better. So the whole idea is the integration of the competency. You cannot teach fundamental of the law in a separate, and after that you say that, I have 2 hours of communication and 2 hours of teamwork in a separate way. If we are managed to integrate this competency and discipline in such a way that while I am learning the first law of the thermodynamic, I can work with my colleague and learn about the teamwork and also present it to industry partner and my communication skill and essential skill, we have always time to deal with the emerging technology. Because every time you have a new thing is coming and you cannot add it to your curriculum. That is a fact. Because the problem is that we were thinking traditionally that, in a silo I have to teach this competency and I don't have enough time. So which engineering education, what they do? No communication, no presentation, no teamwork. Let's have this integral differentiator, first law of the thermodynamic first, because that is the foundation of engineering. But foundation of engineering is to understand each other. I can talk to you and to get what you need, so essential skill can be added as integration. That is we don't need to lose anything, we don't need to give up anything, we have to integrate. Thank you.
Yeah, thank you. I think I'm going to say a lot of the same things that Farzad just said. The students still need to know the fundamentals. I think we would all agree that. But I think there's a different way of teaching it. And I'm going to give an example. For us in mechanical, chemical, thermo is the most hated course to teach and to learn. And there's some fundamentals. And I remember doing a course in thermo when I was an undergrad, and I didn't get it until they presented a heat pump. And then it was like, I understand this. Like, I understand why it's important, I understand. And we have a faculty member in mechanical engineering who his whole life is, how do you recover heat? And he teaches second-year thermodynamics to mechanical engineering students. And they all get the fundamentals because it's in that way. But he's got this living lab in the basement of one of our buildings, and the students go down and they understand, how do you recover waste heat? And so, they're using the equations and they're getting the fundamentals, but it's presented to them in a sneaky kind of way that it makes sense to them because you can understand, well, heat flows from hot to cold. I think that we need to I think as Farzad said, teach the fundamentals, but in a way that allows the students to understand why they're learning the fundamentals. So, you know, the whole, well, because I did 100 hours of thermodynamics and, you know, it was equations and Maxwell's equations and whatever. I'm seeing some smiles in the back because they were the bane of my existence. But the way Jim teaches it, it's just, well, this is why. And I think that they're getting the fundamentals without feeling like they're overwhelmed by the math and, you know, the theory of it all. So I think we have to keep those fundamentals, but I think that there's a different way of delivering them.
Only to phrase it differently is that, as you know, engineering is the applied science. So it means that we have to be able to apply the science that we learn. If we are not able to apply it in 4 years of our duration of our program, good luck that those students go to industry and now start applying. It doesn't make sense. While they are learning, they should be able to apply it in 4 years. Don't expect that, oh, all is the science, they don't need to apply it. When they go to industry, they apply. That doesn't, in any of your sense of in life, you don't do that. So don't do it in engineering.
Marilyn, may I comment as well?
Sure.
Heather, thank you for bringing up the subject of thermodynamics. I have to say, I used to teach thermodynamics for several years at McGill, and only now I can understand why the students reacted to it the way that they did.
Okay, I also had problems with thermo, and nobody told me everyone was having problems. I took it in German, though, too, which was just an added complexity, and it took until I had a colleague who took me to the kitchen and showed me the law of thermodynamics in a kitchen, and then I understood everything much better and finally passed. Very good. So the engineering curriculum, it's also designed to prepare students for a future filled with innovation and success. So what critical changes to the engineering education do you think are required to maintain that? And we'll start with you, Farzad.
So again, I think that we discussed, you are talking about innovation. You are looking to have a graduate that actually define the problem. Until now, the graduate was given the problem. That is the difference in innovation. Most of the innovation came from some engineers sit and say, I don't like any of the solution exist, and I wanted to come up with a new solution. But first they look at that, maybe I have to look at this problem in a different way. That approach in engineering education is critical. How you can engage students in a curriculum, how you can teach them, or how they can learn, that they come to this conclusion and challenge the problem. That is innovation itself. So again, the fundamental of the science, the basic science, I call it natural law, never changed. The gravity never changed. It's a natural law. How you apply it, you need a different thinking, and this is why we call it system thinking. Because now you don't look at the problem in a silo, but you are looking at a system approach. And this system approach is creating a new innovation, new things that we are facing right now.
Yeah. It's funny, I've thought a lot about innovation because I'm involved with a number of innovation programs at McMaster. And I'm not sure it's something you can teach. I think you have to embed it in what you do. And I think you're right. I think it's about teaching them to define what the problem is and then creating a solution to that problem. And the other thing I tell the students is just because you can do it doesn't mean that you should. So we also want to think about, you know, I mean, how many innovations don't ever come to fruition, don't ever come to market, don't ever get used? What's the reason for that? Is it because the market didn't want it? Is it because the market wasn't ready for it? Is it because the solution maybe the market doesn't need it? So I had a colleague many years ago, and his big thing was, engineering is taking science and turning it into things that people can use. And I think that that's where the innovation lies, but I'm not sure we can teach it. I mean, we can, we have an innovation minor and we bring in speakers and we teach the students about starting a company and being an entrepreneur. But innovation is such a, right? I think every one of us would say that we're innovative in some aspect of our lives and something that we do, and some of the things that we design. So I'm not sure we can teach it. I think it's just something that needs to be embedded in what our students do and how they're thinking, and encouraging them to think outside the box, encouraging them to think of a different way of solving the problem while using those fundamental laws of physics. That's where we want our students to go.
Right, so Canada currently ranks 16 in the Global Innovation Index. I mean, this is embarrassing, isn't it? That just tells us that we are not doing a good enough job, especially at educational institutions. Now, so we definitely need to change the way how we approach the engineering education. We have to change, as we mentioned, who we teach, how we teach, and how and what we teach as well. Now, what I'd like to see is our education, engineering education, to reflect what's wonderful about our country, which is having a beautiful mosaic of different ideas, different perspectives, different backgrounds. And we have to really be serious about it. I mean, you can call me an academic veteran. I've done a lot of, together with my team, a lot of new things. Some of them were really good. Some of them beautifully failed, and that's how you learn what to do next. I think what we really need to, and I can offer a few prescriptions, I believe. We have to start with a different way of admitting students. I mean, we have to admit those young people based on who they are. They are human beings with a variety of interests and hobbies, passions, grades. It's only one element of who they are. And I got some of my colleagues from across Canada saying that, well, we admit students only with average of more than 87, the other one more than 91, and so on. If you're going to do it, you're going to create people that look the same, more or less, they think the same, perhaps they dress the same, and so on. That's not what's optimal about our education. So we have to start changing how we admit students. Then what we have to do is we have to change how we introduce them to engineering. I mean, we created a few years ago a concept of passion projects. You see, so rather than when you come to the first year of engineering, and rather than having the first 2 weeks tests in math, physics, chemistry, because everyone wants to prove to you what you don't know, we would tell students let's forget about it. Let's forget about all those maths and physics. We would ask them a question, what is it that you're passionate about? And then they would create groups or individually working on something that they are really, really passionate about. We had a team actually in Toronto that they developed an app that allowed for more efficient distribution of food among those who are less fortunate. The other team developed a water cleaning system that our partners in Ghana were able to implement. And then when you do that project and you understand that in order to optimize it, then you have to know a little bit more about calculus, algebra, perhaps even partial differential equations. And then they would come to us and ask about that help. So you see, they understand that they are not just coming and having all that math courses, that some of them, in my opinion, are completely unnecessary. So what they do is they do understand that some concepts of mathematics and physics and chemistry, that's the language that they have to use in order to get engineering design in place. So that's what we have to change as well. Well, let me be a little bit more controversial, if I may. I think we have to change how we interact with students. I mean, perhaps the worst way of interacting with our students is the way that we are interacting with you right now. I mean, having a prof in front of you, if the prof is interesting and so on, that's good, but if it's not, then it's sort of a waste of time. So what we created, actually, Eddie Evans is here, Eddie and his team, they created this new concept of having a classroom that is full of camelots, round tables that students work around it, and professor was forced to interact with them walking around. So essentially, we were bringing a prof to the same level as we did students. And then a final suggestion, and this is, I know that students are going to like it. I don't think that we need traditional exams. Traditional exams are completely passé. I mean, can you imagine after the entire semester that you're working on something and then on Friday evening you have a 2 or 4 hour exam. If you're not feeling well or if you've had some difficulties in your private, personal life and so on, it doesn't make sense whatsoever. We should replace it with students developing a portfolio of achievement, or in the particular course over the entire semester, and then shared that portfolio with her or his peers, or with professors and with people, our partners from industry. Yeah, so I think we are developing some of those concepts. It's, as I mentioned, you know about this change and then the way baby with a wet nappy and so on. It's taking some time, but if we are committed to it, whatever we're going to do today, next week, next month, next year, it will, and as long as it will be consistent, things will happen. You know how it is in academia. If you want to make change, it's like navigating a transatlantic. You change the wheel, nothing is happening, and then gently is going to move whichever direction it will. Voila.
Go ahead.
Only I wanted to add the first that totally I agree with you, Janusz. So 20, 30 years ago, when I was a student, most of the time in a lecture hall was content delivery, yes? The professor delivered the content. So when I came to Canada, I said that I am not a pizza delivering. I am not going to deliver you the knowledge in your mouth, because now you can go and get it. The same way that you get your pizza. Do whatever, you get it. So now I don't spend time to deliver the content, so now I have a space and time to do all the fantastic thing that you do, yes? So because the technology, thanks to you and your team, the technology allows us that the students can search for the content. So let's now have a discussion about the content. Let's have the same level professor and students have a discussion, and you can challenge each other, and that is creating innovation and a greater need.
And we've had a few topics or conversations earlier about ChatGPT and how that changes the kinds of assessments we want to try to do, what we want to actually ask it and use it in education. I think we all had that little conversation too. So the technology is evolving, forcing us to look at the students, change things. I like the ideas that you've all talked about here. But I'm going to pick up on one thing that Janusz said, that we are doing the typical, we're sitting up here talking and you're just listening. So we're going to turn the tables. And we're going to give a mic out to whoever wants to ask a question of the panel. And I see one in the back there.
Thank you, good night. That was a very insightful panel. I have a question that also might be a bit controversial, and I'm sorry about that. If it's out of place, you can just let me know. Is there a future, for example, for shorter programs like micro-credentials at any of your faculties? Thank you.
That's a very good question. I just came from a micro-credential forum today. Okay. Who wants to tackle it first?
Yeah, so micro-credentials is a buzzword, and in some cases it's a bad word, but I do think that there's a lot of value in students being able to, you know, and I don't know how this is going to fit with accreditation, quite frankly, but I do think that there's a lot of value in little bites of things. So, you know, doing a little project, and, you know, I completely agree, right? Standing up and lecturing doesn't work. Exams don't work. But I think in a micro-credential kind of situation, I think there's a real opportunity for the students to get the knowledge that they need. I mean, we've always done a class that goes from September to December, has a midterm around, you know, Thanksgiving, has a final exam in December. And I'm not sure that that's the best way for the students to learn. Neither is, you know, at McMaster, it's a class from 8:30 to 9:20 or 9:30 to 10:20. I don't think 50 minutes is the right way for a student to learn. So I think we have to think about really innovative ways of delivering content that doesn't feel like it's being delivered, that it's, you know, that the students are participating, and these students are way more participatory than ever before, and they're way more knowledgeable. They have access in their hands, literally, to a lot of knowledge. So what's our role? Our role is to teach them how to take that knowledge and synthesize it and put it together. And a micro-credential is a great way to do that in a bite-sized way.
Yes, so I'm sure that there is some value in micro-credentials, but I have to say I don't like it very much. I'm not a big fan of it, I should perhaps say, especially that we will be negotiating with the government soon some of the grants. Now, and I tell you why, I mean, it's sort of, from my perspective, meaningless. Why micro? How about macro-credentials? How about nano-credentials and so on? It's, however, what I like is the concept, we call it an academic sprint. You see, how students are learning is they are learning by doing things, making things, solving things, rather than spending too much time in classrooms. So what we are testing right now is the following concept. Is, rather than having all those semester-long courses, how about if we had, I don't know, let's say 4-week sprints, academic sprints. That means that we would have a project that would come from a company, perhaps one of the sponsors that we have tonight. Students would work in groups, maximum of 5, and we developed the concept why it should be 5. So what they would do during that four-week period, they would work on finding solutions to that project, and the project would be different for first-year students and second and so on. And during that period of time, they would also need to spend some time on the premises of the company. So if you look at it throughout the year, we would create a sort of perpetual co-op. I mean, I'm a big proponent of co-ops, but not the kind of co-op that we currently have, 4 months, 8 months, 12 months, and so on. So it may work for some people, and diversity is very important. Actually, diversity stimulates vitality. So perhaps it may work very well for our colleagues at Waterloo. They are very well known, and they have a terrific co-op. But like in our case, we want to develop a different kind of a co-op. You know, if you want to play chess with Kasparov, you're never going to win. So you have to find a different way of creating your own reality and implementing it for your students. So perhaps it's about nomenclature or so, but this concept, prevailing concept of micro-credentials that everybody, their brothers and sisters and so on, are using, they don't speak to me. Yeah. Thank you. By the way, one more comment. I hope you don't mind. I mean, we have to disagree on something. When I was a dean here at York, actually, and I had a few associate deans, and we would meet quite often. And I told them that if we are going to disagree on everything, then some of us are redundant. I mean, we have to mind for differences, because that's the only way that we will be able to find reasonable solutions. Go ahead.
Janusz. So, few people in policymakers sit together and try to find a problem, and they find a problem in credential. So, macro credential, you say? So, they connect the credential to the economic development and connect to the global competitiveness. Global competitiveness index doesn't talk about credential. So when my colleague mentioned that we are behind in global competitiveness, they didn't say that we have 100,000 people less in a degree or this, so that with the macro credential, we give them a credential that now we are increasing our global competitiveness. Global competitiveness index talk about a skill to a skill and a skill again. It's all about a skill. So now, as a professional engineer in Ontario, as my colleague Jennifer mentioned, we have to continue to learn and to skill up. Otherwise, we won't be absolute. So now, if you call it macro-credential, good for you. But from credential perspective, I am here 25 years. Honestly, I don't know, is it online? Nobody yet checked my credential. Believe me, nobody asked my credential. And I don't know, Janusz wants to hire me, but he didn't say that first, can I see your credential?
Let's wait for your president to talk to you about it tomorrow. I mean, it will be quite interesting.
Yeah, but I do think, you know, maybe we don't call it a micro-credential, because I too hate that word. But I mean, when I look at our 1P13 course, I remember when they were telling me about it, and this was long before I was in this role, I was thinking 13 units, what if a student fails? You know, what if they fail? But they've actually got it in these bite-sized chunks. So, you know, you fail a module, but then you've got time to go back and, you know, maybe revamp it and do it. So it's kind of like a micro-credential, but it's not called that. So I think, you know, understanding that maybe we need to do things in smaller chunks, maybe that's what a micro-credential is. And, you know, I mean, if we can give them credit, right? Because if we have a student who doesn't do well in one section, they don't have to go back and do that whole 13-unit course. They can go back, or they have the opportunity to improve, and you know, they've got the whole term, or they've got the whole year to figure it out. So I think maybe that's where micro-credentials, in quotes, has a role.
Hi, we have a question from the virtual audience.
Okay.
Are there any models abroad that we can emulate regarding engineering education delivery?
Did you hear it? Are there any models from abroad in other countries in the way they deliver engineering that we should look to adopt?
Look, I don't want to sound a bit arrogant, but the model that a few of us created some years ago, well, not long ago, maybe some 5-6 years ago, in the UK, And it is a model that focuses exclusively on learning, which is the outcome of the process, rather than teaching, which is the input. That's the model that I believe is very interesting. It's a slightly different environment in the UK because it's not as regulated as our education via the accreditation and so on. Now, I'll tell you what the model that I really, really like. And there is a great proverb. It says that if you want to go fast, travel alone, and if you want to go far in life, travel together. It's all about creating partnerships. So I'd like to see in our province having in education, in engineering education, an open system of variety, and creating a universal engineering learning passport would be great. Allowing students to create their own skills and competencies. What do I mean? I mean that we should have a student that will start at Humber and then have the opportunity, because of interest in the particular areas, take courses at Lakehead, and then another year or semester at McMaster, and so on, and then go back and finish at Humber. That way, we will be opening up ourselves to the needs of the young people, that they would like to explore a variety of pathways, to interact with a variety of institutions, to have the opportunity to benefit from absolutely terrific laboratories that our colleges have. And your laboratories are much better than most of the laboratories that I've seen at universities. So but for that, we really have to consider the fact that we are partners, so that there's a difference between collaboration and partnership. Partnership is between equals, and that's why what I like, and one of the reasons that I decided to interact or work with Lakehead is the opportunity that they equal themselves with colleges, for example, and other universities, allowing students from colleges to go straight to the third-year program, accredited engineering program. That is absolutely extraordinary, and they can finish in just 2 years' time. There's nothing like that at the moment, and we should see if we would be able to create a new reality for students, because the reality is that in academia, we're there because of our students and for our students. We cannot forget about that.
One of the things I've looked at, coming into this role, was what other programs are there in the world? And one of the things that has really struck me, and I sat on the ARC too, Jennifer, for many years, is that we don't do a lot of hands-on. We do a lot of theory. We don't do a lot of hands-on. And I think that that's maybe some of the things that we should adopt. So you talked about the British system. They're really good at that. They're way better than that at us. I think French engineers in the same way. So I think, we have to maybe look at providing better opportunities for our students to see and do and manipulate things. We do these labs, but I don't think that we have the same level of capability that students from colleges have, quite frankly, or students from some of these other places. But, I think that the world is becoming global, and if anybody is introducing something really cool, we all jump on it. So I'm not sure that there's a program, but I do think that there's aspects of programs. And the one to me is that we really need to give students more opportunity to see how these things work.
Yeah. So collaboration is the key, and thank you for mentioning that. I give you an example. My daughter is in one of the German university and as a PhD student, and she's supposed to teach one course. So She had access to all the curriculum, whatever she wanted, from any university in Germany to start building her course. She came to Canada in summer and she wanted to access one course. Nobody shared. And she asked the question, it was about the indigenous knowledge. And she asked her senior dean father and said, Dad, are we supposed to share the knowledge? So why we are holding the knowledge to get to? I said, what you mean? I said, I reach all the university in Canada to share that what they have in the indigenous curriculum, that I can start building my curriculum. It has nothing to do with it. And nobody shared. He said, oh, this is my course and I don't share. So the collaboration is a key. Engineering education, as an example, my colleague was asking, for example, the Finland education is a famous on the engineering education, and how they do it. I give you an example. They bring the project, like a project is about immigration in Europe. As an example, I am not going to give an example of engineering. And they want a student solve this problem, immigration in Europe. So what the students do, what should they do? They bring the knowledge from course of geography. They bring the knowledge from politics of Europe, the history of Europe, and religions of Europe. They have this knowledge block to solve the problem. They don't learn, as I mentioned previously, block by block in a silo that eventually they can apply to solve the problem in immigration in Europe. The immigration in Europe in the center of the piece, like the projector. Make a projector, so now you have to bring the knowledge of electrical, mechanical, all to solve the problem. This is, in Finland, is very well known. And we are trying to implement some of these from colleagues over there. Thank you.
Excellent. These are great ideas that you guys have brought forward today that you're actually implementing. They're not just ideas. We're going to end it on one last question. So the Ontario Society of Professional Engineers, we are home to all engineering, the whole engineering community, engineering professionals who already have the license, engineering graduates, as well as students. So what can OSPE do to help the students that you're teaching throughout their education and entering the workforce? Do you want to start with you?
Yeah, that's a tough one. It's funny, I actually had a meeting today with a group of people from Hatch, so great engineering firm, and they wondered, how do we get to your students? How do we get your students thinking about working at Hatch? But I mean just thinking about their future careers. And we have lots of events on campus, but I think you need to engage all of us. So not just the students, but engage faculty members, engage, we've got lots of professionals that, we've got great technicians who have engineering knowledge and background and skills, engaging them in discussions, because I think that there's opportunities for people to realize just what OSPE is and does, and I think that is really not well known. So, I think because the professors are the ones who are educating the students, who are interacting with the students. The TAs are the ones who are really interacting with the students, lab technicians. So there's lots of opportunities to engage the students and to give them the idea. I know that, we do talk about professional engineering and, getting your P.Eng and what that means, and from the perspective of regulation, but we don't talk about what it means to be an engineer, and that's really what OSPE is about, right? The whole, we're all here today because we believe in the profession. We like the collaboration. We like to talk to let's face it, we're a bunch of science nerds. But, you know, I do think that that's what OSPE brings, that PEO, that's not PEO's role, that's OSPE's role. And I think that the students maybe don't see that.
Excellent, thank you. Go ahead, Farzad.
So I am a member of the OSPE and professional engineer for the 20 years. The platform that you create is the key to profession. When I was a student, I didn't have this platform. I was in Europe, but there should be a platform, the role model, working with the industry. Students talk to industry to see perspective, end of the tunnel, you know, and we also learning from our industry colleague a lot, where you are going, what we are doing wrong, because eventually our output of our system, educational system, should be contributing to the society. You are a society. You are representing a professional engineering society. This is our job. Output. Now our students can continue, go to the different discipline. But even if they go different discipline, still having a knowledge of engineers. For example, how we are suffering that our politicians are not engineers enough. Yes? So imagine that eventually we have more politicians who have a background in engineering, have a logic understanding of some of the things that they are doing, the policy making. So the society is helpful, this network is helpful, this platform is helpful. We learn, today I learn a lot from my colleagues. Take a note and go and see that how we can collaborate. I am sure that we will have an engagement after this platform and learn from each other. That is. Thank you for all you do.
Fantastic.
Right. So I see OSPE and PEO as Mozarts of engineering promotion. I mean, that is absolutely fundamental, and you're fulfilling this role very, very well. Now. Indeed, we ought to find a way to promote engineers who are interested in taking on public roles. Last time, I remember we calculated that we have only, I think, 4 engineers as members of parliament, and I think even less so as MMPs. Here, it's very, very important that we have representation, not just representation of our profession, but representation of the way of thinking that engineers may contribute to the public discourse. Now, as you know, we are starting National Engineering Month today, and I think it's a great opportunity for OSPE and for PEO to promote strongly messages around the necessity of, I call it IDEA in engineering. IDEA stands for inclusion, diversity, equity, and accessibility. So it's a little bit more than just EDI. Now, that is fundamental because we didn't have an opportunity perhaps to talk about a lack of diversity in our profession and in our schools. And people have to hear that we are very much open to bringing more women, more BIPOC colleagues, more LGBTQ, and importantly, those who come from underrepresented parts of our society, including those with difficult socioeconomic difficulties. We have to find a way to make sure that they see that engineering is for them as well. I mean, as you know, we were complaining about some things, but the truth is that we are so very honored to be engineers, and we are proud of our background and proud of what we are delivering on a daily basis to advance our communities and advance our economy and improve our environment and so on. And I have to say that I see a golden age for engineering. I mean, on Sunday, I was participating in the Canadian engineering competition. Plenty of engineering students, it was in Waterloo, from all over Canada, and I was on a panel assessing the debates. I mean, these young students, not kids, but students, they are absolutely terrific. They can speak about any and every subject in an eloquent way and in a substantive way. I bet you they are better than ChatGPT. And we enjoyed it. I mean, we enjoyed one another. So the important thing is for our profession to become more, even more creative than we are, even more ingenious and compassionate, and those are the values that we have to embed in our program, so students will be able to take it with them once they become professional engineers.
Excellent. So what I heard basically is OSPE has this role that we can play, bringing in industry, bringing in academia, bringing in the students all in one place, and making sure that they're all starting to see the interaction and the possibilities that exist out there. And then what you were just touching on was making sure that we build that inclusive culture that goes right through into industry with that. So with that, I'm going to turn it back over to Sandro.
So I just really wanted to thank Marilyn, Heather, Janusz, and Farzad for a great panel discussion. I actually have the honor of, I don't know how this happens, but they allow me to sit around the table at the Ontario Deans of Engineering. And I can tell you how passionate they are about student learning, how passionate they are about student success, and how they're really advocating for change with the current learning model. So I hope you heard it today. I also have had the opportunity over the years to sit around the table to a couple meetings with the heads of technology, the Ontario heads of technology, and we have a few reps here in the audience as well, and they're equally passionate as well. So I think there's a great opportunity for change. I hope we take advantage of that because the world has advanced. I think how we need to teach engineering, you've heard today how we need engineers to learn has advanced, and there's some really great ideas we hope to take advantage of. So that ends the formal portion of the evening. Now we do have a cake for Professional Engineering Day. We're hoping to have everyone around, be around the table to do that, but there's so many people and there's not enough room to do that. So what we're going to do is actually have the panelists get around the table, cut the cake. I'm going to ask Jennifer to join us as well. From P.O., and we'll do a picture, and then after that I encourage everyone to go into the foyer for some networking and to talk to the panelists. This year, the opportunity to corner them now as well and challenge them with some questions. Okay, thank you very much.
Sandro, thank you.
Oh, thank you, my friend.